Hello. Hi. Real-time data processing. The moment I said real-time, right? So my voice, when I generated the word real-time, it felt like it reached out to you instantly. But again, there is always a small delay between the generation and the data reaching at its target. So of course there is a delay, but we don't find, I mean, we didn't felt that the data reached with some delay. So that's why we say real-time data, but again, it's not exact real-time. Always it will be a near real-time data kind of thing. So it will always have some or the other delay, maybe in MS. So again, real-time data processing with Go and PostgreSQL. Postgres. So first we'll see why, I mean, Golang, some of its features, why I used it. So Golang has a very good concurrency model. When I say concurrency model, it has a very, when the threads, we have OS threads and user level threads, right? So and Golang has a very good polling mechanism where it chooses the threads very effectively so that the response time of the APIs or any application will be as efficient as possible. Now why? Because it's not using exact OS threads, it's using user threads where it maps these threads to the OS level threads, multiple threads. Again, these are like very lightweight. When I say lightweight, it's like it starts with 2 KB of a single thread. When I take a OS thread, it will be around 2 MB, sorry, 2 MB. So of course, when it's a fixed size and we don't know whether that thread needs that much allocation in the stack space, it becomes difficult for context switching also, whether it's like time consuming or not. So Go decides these things and then allocate the stack space, and it shrinks and it expands accordingly when the data, I mean when the process executes. And then we have, of course, we have GC, so it's memory safe. Again, the strong standard library, like for SQL, it has a package called database/SQL. All the operations, all the functions, and built-in, all the things are in a standard library. So it has a good standard library. And then, of course, growing community. The reason, one of the main reason is like the development time is very faster in Go, because when I said concurrency model, implementing these concurrency threads are like not much difficult in this, because you have very simple syntax for it, and yeah, hundreds and thousands of concurrent threads can be executed. Now, coming to the importance of real-time data processing. So when I say importance, like we all know that the moment data gets generated, we can process the data after some time and we can take time, but again, always we see that we take decisions based on the data which we have. So if we want to take that decisions, so first thing we need is a data. So the first point when it comes is we need a decision making capability. To do that, we need a data. So of course, for this, the faster we process the data, the faster insights we can get it, or the faster decisions we can make. Maybe it's a monitoring system or alerting systems, because those actions need to be taken the moment the alerts got generated, right? So yeah, and again, so let's say we have a dashboard which shows the score of a cricket match or something like that, and users are waiting for the score that gets updated. Of course, customer experience is one of the things that makes real-time data an important thing for any application. Now, what are the challenges in building these applications? Mostly, the first thing comes is how fast we transfer this data to other part of the system. So, of course, we have to keep the latency as low as possible. I know we can't make it 0, but again, we have to make sure that the data reaches fast. And then, yeah, when I say we are building a pipeline kind of thing which transfers this data from one part of the end to other part, we have to maintain an infrastructure as well. So we have to maintain that infrastructure. And then consistency, of course, where the data what it got generated has to be delivered in the same format, or same thing has to be delivered at the last end. These are the challenges. Now let's see what are the different solutions, like how we can build. Like one is like independent systems and one are downstream. Let's see what independent systems are. So when I say independent streaming, so I have a source from where the data gets generated. Of course, these data can be distributed across two systems. Let's say my target is, there is a database which I'm using, and then one is target. I'm storing the database, data in the database for, of course, reviewing, analytics, and everything. And then I'm sending that to different target as well. But there is a problem here. Yeah, if let's say I have a vouchers and I am distributing to the customers. Now I have to store the code of that voucher in the database so that I can verify when the user uses it. And then I'm sending that to my users as well. But if everything goes fine, of course, the target will be getting the data, DB will also be getting the data, and everything works normal. But let's say there is a problem between the data that is getting stored in the database, and my target is getting the data with a very good amount. I mean, there is no connection failure between these two things. So what happens? The customers are getting the voucher, they are trying to use it, but we are not having the data in the database. Similar way, if data is not reaching the target, but it's reaching the database, same problem occurs. So from this we found that, of course, independent streaming is possible, but again, there is a problem of consistency, can be a problem of consistency. So one thing we can do is, we can process this in the downstream manner, meaning first I'll put the data in the database, and then from there, I'll be fetching the data and giving to my target. Of course, it will add some amount of latency, but still, I'm making sure that the data reaches only if it has been entered in the database. So after data is inserted, then I'll pull the data, or my database will push the data to the target. So we have two types of things. Either I can pull or push the thing. Now these things can be done using CDC or any pub/sub mechanism. So we'll see what CDC mechanisms are. Change data capture, as the name itself suggests, the moment the data is being changed, whether it's an insert, delete, or update operation, it has to be captured. And the reason we are capturing it, we have to transfer that to the other end of the system. So we have many types of CDCs. Let's say log-based we'll discuss about log-based, trigger-based, and query-based. And when I say pub/sub mechanism, I'll be like, okay, let my data get pushed by the database itself, and then I'll have one subscriber sitting at the other end of the system, which will be subscribing the data. So yeah, we'll see log-based CDC. So what happens here is, we have a database. Now this database is attached, we'll attach a connector. We have target, now we'll attach the connector to the database. What it does is, every time the data gets inserted in the database, we'll have the records inserted in the val files, which are like log files. Now these are in binary formats or other formats, other DBs has in other, Postgres has in binary format. Now these connectors, what they do is that they extract this data. Again, they have their own mechanism. They read the data and then creates a JSON format or any format which is needed for the particular target, and they push this data into the queue. What queuing mechanisms do? We have different tables, we have different logs coming into it. Now we have to distribute data accordingly. So we'll have a queue which partition this data. We have connectors. Now these connectors are connected to queue, which partitions the data into the different parts of the queues, and the queue data will be sent to the target. So this is one way, and mostly people use this because it has a minimal overload, because we are reading from the log files, and then the data is very consistent because we have insert, delete, and update. All the operations are done. All the operations are captured in this thing. Now, so val files, then passing this to queues, and then I'll attach my consumers to the queue. These consumers will be getting the data and distributing it. Now, we'll have one more thing. Trigger-based CDC will write a function which says that whenever there is an insert or update or delete operation, we'll do the same changes into some different table. We can say stage table. So in that, we'll put the data, and from there the downstream process starts. From either we can query, or again, the val thing can be done. One more is query-based. So here simple, I'll put a process in between database and target. Now this has a polling mechanism. This API will be fetching the data on a timely manner. Of course, we have to add a timestamp in a table so that we can get a data of particular time. Let's say, yeah, we get a data. So we'll query the data, database will give, and we'll give that to target. Of course, in this we have some problems. Load will be more compared to the val readings. And then polling, when I say polling, two polls can have a small data difference and that will not be captured. But again, if I have, let's say, we'll see a small demo where we'll see, let's say I have a cricket score dashboard and I want that to be updated. So I have these things. Now let's say all my readers are checking the dashboard and they want the data to be refreshed without they themselves reloading the page, of course. So what I do is, here I am inserting the data, like score is increased, and you will see that all the users will be getting the data, at the same time. Of course, you will see when I increase the data at very faster rate, you will see direct jump from 3 to 7, but users don't want how the data changed from 3, 5, 4, 5, 6, 7. They just want the current timestamps data. So of course, it's okay if we can do this kind of mechanism. For smaller applications where we don't have to put all the pipeline kind of thing, where connector is there, queue is there, and we are processing that data. So for smaller applications, this works fine. And yeah, so after this, then we have pub/sub mechanism. It's like we are asking database to push the data changes into a queue kind of thing, and we are subscribing this from other processes. So you'll see the demo of it. So we have a database, we have a queue on the same server itself. We can call it as a channel, and then this queue will be filled with the changes done by the DB, and whatever changes we want to put, that we can put. Based on that, the process can take action, whether to poll the data or take the data itself from the queue, if the database is sending the data itself. So that's what, publish the change and then queued in the memory. We have subscribers. So let's see how this is done. Let's say I have, this is the schema. One second. So what I'll do is, I'll create a table which has timestamp, data, and then ID. Now what I'll do is, I'll create a trigger. This trigger is like, whenever the data is inserted, I have to perform a PG notify function. Now what is PG notify function? It's like a notification function which takes the channel name and then data which has to be sent to the channel. Now what I'll do is, I'll create a trigger for it. So whenever the data is inserted, so we have to trigger this function, and then the data will be pushed into the channel. What Golang do, what my program do is, each time the data is sent, I'll have one subscriber attached to it. This subscriber will be listening to the data. The moment it listens to the data, this has to be published to the all the clients which are attached to the API. Now I have two ways to do this. If let's say we are in a meeting and we have a small number of group, like say 15, 20, and 25, we can do this by attaching each people as a subscriber and publish the data accordingly to all of them. But if the scale increases, like if you have millions and millions of users, for that attaching each listener is not a good thing. So what we do is, we'll attach one listener for one API and then listen from them. Once we get the data, we pollingly will subscribe this data to other parts of the clients. Of course, again when I say polling, you have two polling time difference. In that, the data might change. But again, the process in which we want the current timestamp data, which can be that can be feasible. I mean, that can be okay if we do that. So let's say I have this thing. One second, I'll show you the demo. Now, yeah, so okay. So now four people are watching a post which says that how was the talk, and then if anyone likes it, so people say that awesome. Now all the people who are watching this post should be able to see the same reactions done by all the other people. So this is how the reaction number changes at the real time. So what I have done is I have listened one time and then polled this data to all the subscribers who are listening to my API. So yeah, that was my talk. Yeah.
You showed two methods. One was CDC and the other one was PubSub. What if I keep my queuing message queue in front of the external source, take the data inside my queue, and then push it to the target or to the database? What happens then?
So if the queue is publishing the data to database and the target, then again the external source is the queue itself. If it's publishing to only target and your external source is giving independent to the database, then again that connection problem occurs and then
And
data.
what if I do this, that I keep my queue in, this is my external source, it is sending messages to the queue, and the queue then sends the messages to the database, and then the database is in the middle and the target is calling or making the API calls to the,
Which adds to the same pipeline, right?
yeah.
Which we saw for CDC, like external data source and the queue, what
So
you're
it
saying.
combines the CDC and the PubSub model.
So CDC, when I say, of course, they also use external third-party connectors we have to use, and of course they use the queues. So it looks like it's a PubSub mechanism, but what PubSub I was telling is like implementing the queue on the database server itself.
And would you recommend PostgreSQL for near real-time database? Or would I have to use an extension for it?
Again, that depends on the use case. So if I say that we are in a meet, Google Meet, and we have that reaction thing. If I click three reactions will pop up. We have around 200 people. So of course we can have the PGSQL as a thing. But if you have millions of users, we have to test and then check it out.
Any other questions? All right, that's that then. Thank you. Thank you, Darshan.
Thank you, sir.